Welcome to the TechArena, featuring authentic discussions between tech's leading innovators and our host, Allyson Klein. Now, let's step into the arena.
Welcome to the TechArena. My name's Allyson Klein, and today I'm delighted to be joined by Ron Nevo, CTO of cPacket Networks. Welcome to the program, Ron.
Thank you.
Why don't we just start with an introduction of you and your background and the background on cPacket?
Sure. Yeah, I'll start from the beginning. So I started with networking in the 90s with Qualcomm, doing cellular, CDMA. I moved to the US and was one founder of a company that was doing Wi-Fi Bluetooth around 2000. The company called Mobilian was acquired by Intel. And I spent 10 years in Intel, either on the incubation group of Intel, trying to create ventures within Intel to new businesses, or the wireless group. And then I joined cPacket about 9 years ago. I'm the CTO, started as a VP of engineering, now the CTO of the company. The focus of cPacket is monitoring of high-speed networks, all the way from 10 gigabits per second to 100 gigabits per second. In the context of the observability, that would be network observability. We do have products that serve as enabling security, specifically NDR solutions, so security solutions that are based on packets delivery and packet capture. But for the most part, we are focusing on network observability at very, very high speed.
This area is something that's quite interesting to me. And it's interesting not because of where the technology has been, but where it's going. And
Mhm.
one of the things that I think about is that, so many organizations are looking to get the most out of their investment in hybrid cloud. And, one question that I wanted to ask you before we even got into observability is what's your take on why organizations are seeking hybrid solutions? And how do you see this developing with your customers?
Yeah, I think it's a great question. So it's the right place to start, right? Because at the end of the day, there has to be some business rationale of people doing things. And what companies are looking for is, on one hand, to be able to innovate really quickly and really fast. On the other hand, they have to deliver high reliability services. So in the context of hybrid cloud, what they do is they look on their monolithic applications that worked reliably for many years and they know how to operate. And they look at the cloud and they say, well, how can I innovate faster? And the reason that they need to innovate, we work a lot with banks. So they're facing a really strong pressure from what they would call neobanks or fintech companies that come up continuously with new services, come up with continuously new innovations, with better user experience, and they have to be able to be competitive with that. That's true for any other company, right? If you don't innovate, you just stop. And then they look at the cloud, and the cloud, if you think about it as a platform for innovation, it's amazing, right? You can bring up a servers in no time, start a new application, test it, scale it. So from agility perspective, cloud is a great place to innovate and scale. The challenges are going to be as you start scaling the costs and the reliability, I would call resilience. I think in reliability, you can think about robustness. So cloud is very robust, allows you to operate on multiple availability zones and run things in parallel. But resilience is about, okay, what happens if something bad happens, how quickly you can recover. And cloud is not great at that today, or at least it's a challenge to do. So they have to balance the things that they want to be always on versus the places where they need to innovate. They want to be able to take advantage of third-party services. So if you go to a website today of any of the big banks, there are 120 applications that serve it. Some of them will serve you the right ad, and that will come from a third party. So all these combinations of challenges of being able to deliver very quickly a lot of new services, a lot of new user experiences, and still maintain robustness and resilience causes them to effectively divide their service chain partly between the cloud, part on the cloud, part in the data center. So you end up with this mixed environment, which we refer to as a hybrid cloud or hybrid multi-cloud in some cases.
And just to get a little bit more complex, there's some added challenges. You talked about the resilience, but there's also some added challenges from a management perspective
Mhm.
within hybrid approaches. Can you comment on what is creating the challenge for IT to actually oversee their services when they move to hybrid?
Yeah, I mean, the situation is, as I described, there are 120 or so applications. So one of our big banks that we work with has 100, I think he called it 127, but let's call it 120. And these are services that partly were written by the bank, partly are third party, and partly are coming from vendors. They are deployed in 4 different data centers that they own across the US. They have services that run AI ML services and sometimes image scanning services that run in the cloud, either natively or something that they wrote. And some of them are services that they get from third parties, so that complement some of the solution. Orchestrating that is not a simple task, right? Making sure that they're all up and running and optimized to deliver the end user experience they expect is not an easy one. Another interesting challenge, again, within this context, I'll just use the same example. The example that the architect was, or the guy that is responsible for managing the site was giving me is that if you think about the normal, quote unquote, normal web company, they try to optimize to the 98th percentile or 99th percentile. And his point, well, if you are a customer and you log into your account, you have maybe 5 accounts that you need to watch. It's fine, pretty easy for me to deliver. But the 0.1% of the customers they have 1,000 accounts on their homepage. And these guys also know the phone number of the CEO of the bank. So he has to optimize for that, right? There are no compromise in the way that you have to work. So it's not only complex, you also cannot have any shortcuts. You cannot just be kind of, it's good enough, right? I'll do my best to deliver. He has to deliver to the highest strictly standards.
That makes sense. Now, observability is a topic that's been gaining incredible attention in data center circles.
Mhm.
Can you just start with a definition of the observability and
Mhm.
how this definition has changed over the last few years?
Yeah, I think the way I see observability, I think we're using things that were obvious to in other disciplines, and now we're moving them into the IT arena. And uh, in order for you to understand, or in order to operate a service or to write an application, developers are used to have a debugger. And what a debugger will do is allow you to stop the system, see inside the system in details what's going on. So really observability is about the ability to see what is going on in your system and understand using what you're able to measure and see the root cause of the problem. Another analogy that I like to use is an X-ray. So you can see that if somebody complains, then maybe it's a broken bone, but you do need an X-ray to see that if you want to really understand what's going on. And beyond that, if you go to an MRI will not only tell you if it's a bone, it will also tell you if it's a tear or meniscus, or it is a bone, or just you're complaining, right? So there is also within the ability to go into the system, it's a question of what is the resolution? Can you see the soft tissue and not just the bones when you look into the system? I think it's an evolution. I think some customers or some companies always had the different abilities to look into their operations. I think observability today, you can divide it into kind of four components. Many times people, it's kind of the story about the elephant and the six blind people that touch the elephant from different places. And one sees a rope, so the one that touches the leg sees a wall. So I think observability is a little bit like that. The four components are coming in from the network. I'll start from there, right? Is the ability to see what's going on in the network. You have application performance monitoring that is based on logs and traces, allowing developers to put traces inside their codes and understand what's going on. You have people that come from the infrastructure and are able to utilize telemetry, whether it's a NetFlow or CPU utilization or memory utilization. And you have the people that say, well, it's all about collecting and indexing the data, right? And putting it all together. So in reality, from the CIO perspective, they need all four. Because at the end of the day, they don't really care where the breakage happened. It has to come together. So what we're seeing today from evolution is really companies that are building kind of an observability task force across their company and trying to put all these things together such that they are able to sell the CIO a unified picture and not just say, okay, go talk to the DevOps team or talk to the network team or talk to the infrastructure team.
Now, cPacket has a number of solutions in market. Can you just walk us through the suite of solutions and why you've assembled them the way that you have?
Mm-hmm. Sure. Yeah, I think that we start from what's called packet brokering. So packet brokering is the ability to take packets from many, many sources and delivering to many, many consumers. So in the network space, the highest quality of data that you're able to start with in order to understand what's going on is to see the packets. And when you look at a data center, you might have 100 or 200 ports that bring in data, or meaning packets, whether they are from optical tags or spans or remote spans, different sources of packets. Usually with an enterprise, you'll have sometimes 7, sometimes 2, but many, many tools that need these packets. And the first task of a packet broker is to be able to take the right packets, deliver them to the right consumer. And you only want to deliver the relevant packets to that consumer. So for example, if you have a device that doesn't know how to decrypt packets, you have no reason to deliver encrypted packets, or you may only deliver the header of the packets. So it's this situation where some people some packets have to go to multiple places, some packets have to go to one place. So that's what a packet broker does. cPacket has unique capabilities of doing a lot of the analytics at the port level, a lot of delivery and the processing at the port level, which give us a very unique ability to scale. Mm-hmm. So that's the first line. Second line is what we call packet capture and protocol analytics. These are devices that allow us to capture the packets for later analysis. But the more important thing is that we're able to do the network analytics in real time as we save things to disk or before we save them to disk. So that allows us to extract the metadata, which is what's going to tell other tools, or it's going to tell the user what was the latency, what was the utilization of the network, and so forth. And then on top of that, we have what we call a visualization, or cClear, which allow you to get a more visual picture of all the tons of metadata that we generate in the C-stores. The idea is that these CVUs and C-stores, CVU are the packet brokers and the C-stores are kind of observability nodes. We're able to deploy them all the way from 100 or 400 gigabits per second ports to the cloud. We are able to put them on any of the clouds. Each one of them is independent and can do a lot of work on its own. But at the end of the day, you want to aggregate it to a unified picture. You don't want all of them to send alerts all the time. So that's what the cClear does. And one of the things that we're getting ready to introduce is an AI ML-based solution that allows us to see all these, to see the data, understand what is normal, what is abnormal, and then collect all this abnormal into something that a user can understand and not overwhelm them with alerts, but just say, here is a card and this is what is going on in your network.
So, you just did a fantastic job talking us through a very comprehensive suite of solutions. Tell me what it's like for a customer to deploy that, and how do they work on deploying those solutions together so that they've got something that's unified?
Yeah, so a lot of that is in the architecture. We are starting from packets, right? So it's a very unique resource. And I would say the alternative would be something like net flows. And we'll talk a little more about the difference. But net flows are being generated in the infrastructure. You can get them from many, many places. But when you actually want to see packets, it's usually not possible to put it everywhere. So the first thing that you will do is identify what are the middle boxes, what are the key points in your network that something might go wrong. And these will be typically load balancers, firewalls, WAS, so web optimization devices. And these devices, you want to be able to see what's happening before them and after them. So that will be the hundreds of ports that I mentioned in a big data center or typical data center for our customer. So the first thing you see, you map these ports and you say, okay, these are the ports in my networks that I want to get packets from. You route them into the packet brokering layer. There's some topology there that you need to think about, but too much details, I think, right now.
Hmm.
And then behind that, you will put the tools that can be the stores from cPacket, that can be security tools from other companies. Sometimes they have homegrown tools that they will deploy. And as I mentioned, you have to decide on the brokering, right? These consumers to producers. So you'll do that. For us, because we have the single pane of glass, the See Clear, they are able to see the complete picture, both from manageability perspective, because you want to be able to upgrade the software and configure it from one place, as well as all the information in one place.
Hmm.
So that kind of more standard way to do it. And they will repeat the exercise on every data center, and they will repeat the exercise in cloud. Cloud, there are little different constraints, but similar idea. And then map their service chain across this environment. But because what they want to know is that if something is breaking across the service chain and where it breaks.
Makes a lot of sense. So here comes the $1 million question, which is, this is incredible capability. We've said that there are some challenges in hybrid environments and multi-cloud environments. What's next, do you think, in the observability space? And how is cPacket positioning itself to lead?
Yeah, it's probably more than a million. I think we estimate it in 20 billion. So, okay, I think the first thing that is next is when I started in cPacket and started meeting customers, the first thing I was like, oh, we can send alerts. And well, don't give me any more alerts. We have 400,000 of these. If you have something relevant to tell me, then by all means, but don't give me alerts. That doesn't help. So I think the really holy grail is the observability solution should tell you the relevant information. And the way we think about relevant information is, if I'll take a step back, if our customer, which usually is a network operation engineer, director of operation, gets a phone call from a user, and a user can be a person or can be an IoT algorithm or high frequency trading algorithm, the complaint can be divided into three. Either something is too slow. We certainly experience that in the ultra low latency, where slow can be a few nanoseconds. So either something is too slow, or the quality is bad. So, Netflix doesn't come up well, the Zoom calls are pretty bad, or something of that nature. Or I cannot connect, right?
Mhm.
So these are the three things that people call to complain about. In order for them to root cause the problem is really about answering what we call the four W's. It's what happened in actually happened, when it happened, because not always it's correlated to the phone call. Where, which usually is the hardest thing to answer, is like where things actually happen, and then why. So the what, when, why, and where. And um, what you want to do is to be able to answer all these four questions as fast as possible, right? That's part of the
Mhm.
resilience. Once they know all this, usually the solution is quite easy. The hard thing is to know the solution. So today, I kind of mentioned, right, we have huge amounts of data, right? Billions and billions of packets that we look through in a day in a normal customer. And it's really nice. We're able to generate really nice graphs and dashboards that show the problem. The problem is that there are so many dashboards that after the accident, they can go and incident, they can go and say, oh yeah, this graph showed the problem. But you can't really monitor all these graphs all the time. You also not easy for you to set hard thresholds because a normal network, a normal service always have some issues. So how do you know that this
Mhm.
level of issues is higher? So really the holy grail is the ability to deliver a card that tells you, I'm seeing this branch in the UK and every day around 8, the latency is higher than what it should have been or higher than what it used to be. And these things come and go, right? Until somebody calls, there might be 7 days before the things got worse until somebody made the call. And from our perspective, it translates to, thousands of anomalies, what we would classify as anomalies. But you really want to be able to take these 1,000 anomalies that happened over multiple days, collect all of them, make sense of them in one place, and give them a card. I think the holy grail will be the 4 Ws. For us right now, the objective is to get the 3 Ws. I want to tell them what happened when, and when I mean when, it can be every day around noon, right? It doesn't have to be just one point in time. And where the why can be many reasons why. It can be someone misconfigured something, can be a software update, can be 1,000 things that seems to me right now beyond scope of delivery. But we certainly think that the ability to deliver these three, the what, when, and where, is feasible in the short term.
That sounds exciting. I can't wait to hear more as you make progress.
Yeah.
This is a really important space as we continue into more and more distributed computing environments. It's just critical. And I love the work that you and your team is doing. I'm sure we're piquing folks' interests online too. Where can folks engage with your team and learn more about the great solutions you're bringing to market?
Yeah, the best place will be our website, www.cpacketnetworks.com. I believe cPacket will go there too. That's why I'm the CTO. I'm like, oh, I don't
You don't
know.
you don't pay attention to the
I
URLs.
just a technology, yes.
Well, thanks so much for being on the program, Ron. I think you were the perfect guest for this topic as the CTO, so
I
thanks so
really
much.
appreciate your time. Thank you so much.
Thanks for joining the TechArena. Subscribe and engage at our website, thetecharena.net. All content is copyright by the TechArena.